How can AI and smart technologies improve or innovate your business processes in the water network? During this session, we are going to try to answer to this question by analyzing some real-world use cases that we implemented so far. As we were saying, my name is Lucio Machetti. I am the R&D Manager in Terranova and board member in HPA. Terranova is a leading provider of software solutions for the utility market, encompassing gas, water, electricity, and waste management. On the other hand, HPA is a spin-off of the University of Verona, which is part of the Terranova group and develops AI solutions. First of all, I would like to introduce you to a future-proof approach to address the challenges of smart metering. In Italy, we started a massive rollout of power meters in the early 2000s and the massive rollout of gas meters in 2010. Water metering is a little bit more recent phenomenon, but still we have projects and pilot projects counting up to 100,000 devices. So we got a great experience from these projects, and that's why we are here to share with all of you. This is the overall architecture of the smart metering platform that we are using to support all of these projects in Italy, in Spain, in US, and in other countries. As you can see, it's quite complex, but today we were going to focus only on 4 modules: the MDM, which is the Meter Data Management System, which provides alarms, diagnostics, and APIs to be integrated with the external systems like billing system, CRM, ERP, and so on and so forth. The head-end system is the software module in charge of communicating with the meters on the field through point-to-point communication, so GPRS or MBIT, for example. The network manager is the module that you need if you are managing concentrators and radio frequency meters, for example, LoRaWAN or 169 megahertz. Last but not least, we are providing also a mobile application to support the local operator, the field operator, to locally program the meters on the field for the first installation or maintenance operation or stuff like that. Today, we have no time to dig into more details, but I do want to stress that a smart metering platform, in order to be a digital enablement platform, must have at least a couple of features. Since water meter manufacturers are producing meters having several communication technologies like MBIT, LoRaWAN, and so on, and since no one is prevailing over the others, because they both have pros and cons, in our opinion, it's better if your platform is meter vendor and communication type agnostic to avoid being locked into one technology type. And that's why we integrated so far in TMM 150 different models and more than 3,500 different firmware versions. The second part of the presentation will be about AI use cases in smart metering. The management of the battery in battery-powered meters is the problem number 1. Of course, you can face this problem by reducing the traffic generated by your head-end system, but sooner or later, you will have to replace the battery. And here you have 2 options. The first one is by adopting condition monitoring. So you basically constantly monitor your assets, your meters, and as soon as you detect a failure, it's probably because of the battery. So you have to send someone on the field immediately. That's why I'm saying that you have less time to organize, because in the meantime, the meter is not sending data to your head-end system, so you have a problem. This is a reactive method that acts after the failure. The alternative approach we are proposing today is by using predictive maintenance. So basically, we trained an AI model using the battery consumptions of the meters that we are managing so far, in order to predict the time in which the meter will probably stop communicating with the head-end system, and send someone on the field to replace the battery just in time to avoid the failure. This is the proactive method that allows you to have more time to send someone on the field, and maybe you can also combine different tasks to avoid sending someone on the field just to replace the battery. The next use case is about the validation, estimation, and editing, which is a process that allows your operator to fill the gaps in the data that are coming from your meters. So if there are some missing data in the consumption profile sent by your meters, you have to replace it with realistic ones. So in this case, you are passing from version X of a consumption profile which is incomplete but real, to version X plus 1, which is estimated, partially estimated, but complete. The way you are estimating the missing values strongly impact in the precision of the data that you get. The traditional approach is by using deterministic algorithms. Deterministic algorithms basically uniformly distribute missing consumptions in the missing values. That's okay, but they are not so precise. This doesn't allow you to take decisions on this data because they are fake data. The alternative approach we are proposing now is by using AI, and our AI-based algorithms outperform deterministic ones because they are more accurate and they are able to better take into account changes in the user behavior, thanks to the clustering and forecasting techniques that we built into Tina. Tina is our AI engine that empower all our solutions with AI. The same techniques can be used to detect if there are anomalies in the data sent by the meter. So basically, you can compare real values coming from the meter with the estimated ones. If there are differences, probably this means that there are anomalies in the data. That can be frauds or leakages. And you all know how important it is to detect if there are anomalies, leakages in the water network. It's so important that in Italy, we started a special research project with some partners and the University of Florence. This is a project funded by the Ministry of University and Research. And in this project, we are going to use large language model like ChatGPT and its brothers, or generative networks in order to detect if there are leakages, anomalies in the data sent by your network. This is a very special project, so I cannot say more than this, but if you are interested, you can ask in our booth later, and we will be more than happy to provide more details. The last use case that I'm going to present to you today is using computer vision techniques like machine learning, deep learning, QR code, OCR methods in order to extract information out of the images you might have of your meters. Information like the meter readings, serial number, brand, the meter model, and so on and so forth. This applies to a couple of use cases. One is when you have your field operators that goes on the field. They probably take some photos of the meter after a meter replacement, a meter installation, a meter reading. So you have a set of images that you can leverage in order to automatically extract those information and populate your data in order to avoid manual input. The other use case is can be applied to the images sent by the final customer through the web portal of the selling company for communicating the self-readings. This way, again, you can extract those information, avoiding to have a human operator to do that. This is my last topic, and here I would like to introduce you to a new way to conduct searches within your document base. So let's say that you have a document base, can be a list of PDF or Word or something, in SharePoint or network server or whatever. Traditionally, when you would like to search for some information into a document base, you have to select some keywords. Ask the system to look for those keywords into the documents, and the system will respond you back with a list of the documents containing those keywords. Then it will be up to you to combine all the documents and get the response you are looking for. This is something we are used to do, but the approach that we are proposing today is by using WISE. WISE is a generative AI search assistant that allows you to interact with your document base by using natural language. So you can simply ask to WISE, ¿cuál es la duración esperada de la batería de un medidor de agua? And WISE will respond you back with the response. It will be up to WISE to search into your document base and find the single pieces of information, combine all together, and respond you back. We are passing from minutes to seconds to find the very same information. This is how it looks. So basically, you can prompt your question, and WISE will respond you back with the response by using the same language of the user. So if the user is asking its question in English, it will respond you back in English. If the user is using Chinese, it will respond you back in Chinese, regardless of the language of the document. This is really, really important. Here, I tested the product just for this session, and I used an Italian document and asked questions both in English and in Spanish. It's also important to say that after the response, there are the list of the references used by WISE to build the response. So if you click here in one of those references, the original document pop up and allows you to see where it takes the response. My presentation is finished. To conclude, we have seen how important it is to use AI to improve and innovate your business processes like never before. Muchas gracias.